So we are starting this from the scratch. And most of you mentioned ki sir, this is not our one of the best chapter, but we can consider in chemistry it is one of the worst chapter, if not the least prioritized. Electrochemistry, as the name suggests, electro means electricity. When you involve electricity and you are studying the chemical part related to the electricity is the electrochemistry. I'm not saying you are converting electricity into chemical or you are converting chemical into electricity. No, I am just saying you are involving electricity by using some chemical. Okay, by using some chemical. What happened? There are two situations. If you have chemical and using this chemical, you are producing electricity. So, Hina, what kind of cell produce electricity using chemicals?
Chemical cell.
Chemical cell.
I don't know, sir.
Chemical cell.
Sir, chemical cell will have chemical, sir.
Electrochemical cell.
Yes, sir.
Electrochemical cell. So this cell produce electricity by using chemical. Next, Sarah, is this spontaneous process or non-spontaneous process?
So spontaneous.
Spontaneous. Jordan, what do you mean by spontaneous?
The reaction happens without uh it basically doesn't need much of an activation energy. It happens in a very
Hmm.
fast manner.
Correct. So you like it when we say ki any reaction occurs spontaneously, it means it is ready to proceed. This reaction is ready to proceed. I think this girl have some issue with the network. Yeah. So yes, let me finish this. So we have two type of reaction. One is spontaneous reaction and second is non-spontaneous reaction. Chandana, what happened in these two reactions?
So can you just scroll up for a minute, sir? Yes, sir.
Yes. So Chandana, what happened in any non-spontaneous reaction and spontaneous reaction?
Sir, spontaneous reaction takes by its own.
Takes by
Yes,
spawn.
sir, without depending on it.
Okay. And spontaneous reaction? Chandana.
Yes,
In spontaneous reaction, more energy is released. That's why when you correlate this spontaneous reaction with your 11th class thermodynamics, it says that your delta G value is negative, means energy is released overall. entropy is increased, so your entropy will be positive, and overall your enthalpy is negative. Exothermic reaction means whenever any reaction happen and this reaction ultimately lead to release of the energy, it's good. Your entropy is increasing. And exactly opposite happen in the non-spontaneous. Overall, you need to do lot of energy to proceed the reaction. Overall, movement will reduce. Overall, you this is a endothermic reaction. So whenever you proceed any reaction and you get energy out of it, it's good for you. That's what spontaneous is. Any doubt, guys? Sandana, Jordan?
No, sir.
No,
Okay. So you will see कि whenever a reaction is exothermic, it means it is releasing energy which is good for us because that's what we want. Example, why we are eating food? Because this food ultimately will give us energy. That's why it is spontaneous reaction, breakdown of glucose. Correct? But formation of glucose is not a good thing. Like if you are making from the small chemical, anabolism, formation of glucose is not a good thing by anabolism process. Why? You need to invest a lot of energy and net you don't get energy. Understood? Anybody have doubt? Anybody have doubt, guys? So this is the electrochemical cell we're going to read in this chapter. Other than that, we have electrolytic cell. In this electrolytic cell, what happened, Barinder? What happened in electrolytic cell? Barinder.
Yes, sir.
What happened in the electrolytic cell? Spontaneous or non-spontaneous?
Non-spontaneous.
Non-spontaneous because you are wasting your electricity. No doubt you are getting chemical, which is important, but you have to invest a lot of energy. I'll give you the simplest example where we can use both of them in the same system. So, Hina, can you give me any example like that?
Like what,
You,
sir?
Sarah,
Sir, like what?
my question is, can you give me example of a reaction where you have both electrochemical cell nature a system where you have electrochemical cell nature and electrolytic cell nature?
I don't know, sir.
Sarah,
No, sir, not sure.
Jordan,
Sir, can you like repeat the question again, sir?
my question is tell me a system where you have both electrolytic cell and electrochemical cell and it's very common in our life.
I want to say solar cell.
Solar cell. Chandana,
no, sir, I'm not sure.
Varinder,
Sir, galvanic, sir.
galvanic cell. Pratigya,
Galvanic, sir.
galvanic cell. Answer is your inverter. Your inverter is the simplest example that have both of them in a same system. Your inverter. When you don't have your electricity in your house, your inverter will produce electricity using chemical. So this is electrochemical cell. But when you get back your electricity, your inverter will charge and electricity convert again into chemical. So electrolytic cell. Tell me, guys, does it make sense?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so that's why when we see this chapter, we feel, ki, sir, this is very boring chapter. We can't correlate. Yes, we can. We have like battery, whatever discharging is actually electrochemical cell. Battery we have in our mobile is electrochemical cell when chemical will produce electricity and our mobile screen will work. But when we are charging the mobile, electrolytic cell system is working. Makes sense? In watch, you have only electrochemical cell, no electrolytic cell. Why? Because no um, this no charging. Correct? The charging is not possible. Any doubt, guys?
No, sir.
Okay, so Rayan, let me know if you can hear me clearly. So, guys, we have these two type of cell, and this chapter is whole about electrochemical cell and electrolytic cell. Electrochemical cell where you produce electricity, and electrolytic cell as name suggests, electro means electricity, lytic means breakdown. Your electricity will break into chemical. Breakdown of electricity will happen, and it is responsible for the deposition of some chemical. So these two type of cell we have in our syllabus. First will be the electrochemical cell. Any example of electrochemical cell, Tuhina?
I don't know, sir. I don't know anything in this chapter, sir.
Okay. Sarah? Electrochemical cell basically convert your chemical into the electricity. Example of this electrochemical cell is Daniel cell. Very popular.
Lithium ion batteries, no?
Yes, Daniel cell. So what happened in the Daniel cell? You have copper and zinc. You have two important chemical present in this Daniel cell. One is copper, second is zinc. What they do? Example, uh, Jordan, which one will be lie below in the electrochemical series?
So, I didn't understand the question.
Like if you compare zinc and copper, which one lie below in the electrochemical series?
Copper.
Copper. Yes. Pratigya have network issue. Pratigya, can you hear me?
She isn't there, sir.
Okay. Just give me 1 minute.
So, can you just show this notes, sir?
Yeah. So what happen if you take electrochemical series? Jordan, in electrochemical series, you place many elements according to their reduction potential. Okay, you can take oxidation potential as well as reduction potential. This,
Sir, can you scroll up?
yes, I will just give me a minute. Huh. So, example, if you see this series zinc and copper, so reduction potential of copper will be plus 0.34 volt and zinc is minus 0.76 volt. These are the reduction potential. These are the reduction potential. What it is telling us when we study about the reduction potential of any element. Whenever reduction potential is high, element can easily undergo reduction. When reduction potential is high, element can easily undergo the reduction. If reduction potential is low, then it means element will undergo oxidation. Correct? So, example, Chandana, if we compare these two elements, then what would you say ki which element will have more reduction potential? Copper. It means copper can undergo reduction. And when copper undergo reduction, what will happen? Reduction means gain of electron. It means copper will gain 2 electron and it will convert into copper 2 positive ion.
Yes, sir.
Zinc have low reduction potential value, so this zinc will undergo oxidation, and here we have loss of electron. It means zinc will undergo oxidation by losing 2 electron. Got it? So that is what telling us which element will undergo oxidation and reduction. Okay. Anybody have doubt? If you don't have any doubt, so how you will design this electrochemical cell? You will take two beaker. In this beaker, you will have two rod. Two rod means two metal rod. In this situation, example, you will take one zinc rod and one copper. Okay. So you know zinc will undergo oxidation and lose two electron. So electron will move from the zinc to the copper. Correct? Electron will move from zinc to copper. So electron will move from the zinc to copper. Barinder, what will be the direction of the current in this situation?
Sir, copper to zinc.
Copper to zinc, because direction of current is opposite to the direction of the motion of the electron. Correct? If our electron movement happen from zinc to copper, then current will move from copper to zinc. Okay. And to make the complete system, you have salt bridge that connect both the beaker, and there is a continuous flow of the means electricity formation. Okay. But in this situation, you need some external potential to manage all this. Okay. If external potential is less than 1.1 volt, what will happen? Electron will move from zinc to copper. Current will be from copper to zinc. In this case, you know, zinc is converting into zinc 2 positive. So size will reduce, mass will reduce. Copper, from copper to positive, will convert into the copper by gaining electron. So it copper size will increase. Any doubt, guys? Mass increase, size increase. Okay.
So can you
So
go up? So you're moving a little bit fast. Like I'm understanding, but I'm not able to write down the notes.
okay, sure.
I took screenshots so you can move on.
Yes, done.
Yes,
Rina,
yes, sir. Yes, sir.
hmm. Anybody have issue?
थोड़ा और slide up कीजिए.
Am I going too fast, guys?
Yes,
I'm
नहीं
with
like,
the
sir, नहीं
diagrams
अभी
and all.
no
like,
sir.
explanation, no, sir, but the notes you're going a little bit fast. I felt.
Okay, I will give you time to write notes. Okay, don't worry. Whatever you can write, write. If not, it does not mean that you are not supposed to write the notes, but you focus more on the understanding. Okay. I think this girl is facing problem again and again. Rayan, can you hear me? If you can hear but you can't speak, you can text in the chat box.
Sir, I don't think she can hear you because her mic is not connected. Like, I don't think she's connected to audio.
Okay. But she's connected to video.
So that's probably because her device has a camera.
So the video thing is just standard. It shows no video because
Okay. Mm. She tried so much from like different devices and again connecting and connecting, but still no. Like none of you face this issue continuously. So
Sir, I think she
what?
just has to connect to audio, sir.
so if
Okay.
you join with your phone, I think that's the issue because it never lets you join through audio directly. It asks extra after the joining the meeting.
Let me call her because it's not her fault. She been trying. You guys were right. What happened is she is we'll see. So so what actually happened? You should know what is the meaning of oxidation and reduction. Example, in this case, zinc is undergoing oxidation by losing the electron. So zinc lose electron and zinc convert into zinc 2 positive ion. So you can say this zinc undergo oxidation. This zinc undergo oxidation. And copper, you know, undergo reduction, gain the electron. After gaining electron, copper, eh? What is this? 1 minute, guys. This is wrong. So if you see this copper 2 positive will gain 2 electron and it will convert into copper. Got it? So here I wrote it here correctly. Zinc 2 positive copper 2 positive convert into the copper. So this undergo reduction. So you have two half cells, oxidation and reduction. I think this time she will not have issue, I guess. Do you guys get voice when like I am speaking and like her camera and voice is not there? Can she hear me?
I don't think she can hear you, sir.
You won't be able to, like, she can't hear you, sir.
But she can see the screen?
She'll be able to see the screen, but
Maybe.
yeah.
Like how many of you face same problem?
Sir, I used to during online class.
I use
Like during
Microsoft
COVID.
Teams, I don't know.
I have one. मेरी आवाज आ रही है स्क्रीन के थ्रू? आवाज बिल्कुल नहीं आ रही। अच्छा तो फिर एक काम करो, कॉल पे ही रहो और यहाँ पे स्क्रीन दिखता रहेगा तो नोट्स नोट डाउन करने हैं। ठीक है? हाँ। तो वी वर डूइंग इलेक्ट्रोकेमिस्ट्री वेयर वी रिवाइज की chemical form electricity. Such device is known as electrochemical cell, where chemical energy convert into electricity and it undergoes spontaneous reaction. Second, when electricity produce chemical, this is electrolytic cell and it undergo non-spontaneous reaction. Spontaneous reaction means reaction in which we get energy, which is good thing for us. We get energy. Delta G negative means we get free energy, exothermic reaction, like how we get from the food. Non-spontaneous reaction means we have to invest energy. This is the loss-making process. That's why we always prefer spontaneous, exothermic, and a reaction with delta G negative. Electrochemical cell example is Daniel cell, a cell that contain two components, copper and zinc. If we consider electrochemical series and taking care of these two elements, zinc and copper, then copper, according to this series, have plus 0.34 volt, means more value. And what are the more values? Actually, these values are known as reduction potential. These values are known as reduction potential. Whichever element have more reduction potential, such element can easily undergo reduction. Here, copper can easily undergo reduction by gaining the electron. But element that have less reduction potential will undergo oxidation. So zinc will undergo oxidation because low reduction potential. Okay. So this is always comparative. It means two element reduction potential will be given to you, and based on that you have to identify which element will undergo oxidation or reduction. Right? Because zinc lose electron, so electron will move from zinc enter into the copper because copper gain electron. So direction of the electron movement will be from zinc to copper, and current direction is always opposite. That's why copper to zinc. This is possible only when your external EMF or energy is less than 1.1 volt. This is extremely important because whatever I taught so far is also given in class 11th redox reaction. What is oxidation definition, reduction definition, what is the direction of current you have in current electricity. But here, if value is less than 1.1, it's good. Like this will produce proper electricity with right direction. Second option, if EMF of the cell is exactly 1.1 volt, so there will be no electron flow and no current. Why? It's like external internal value are same. Overall, there is no movement of the electron. External EMF and internal EMF when become exactly same, then net movement of electron will be zero. No electron net movement, no current. Any doubt, guys?
No, sir. No, sir.
No,
No.
sir.
Hmm. So, so it means when external potential is less than 1.1, it means your internal value, internal zinc, copper are working. But in third situation, when your external value is too high, then it will influence your value system. It's like, example, you have joint family. If you are strong enough, then your enemies who are trying to destroy you, then you will work smoothly and your enemy cannot harm you. And in that situation, electron move from zinc to copper and current move from copper to zinc because direction of current is always opposite to the movement of the electron. But if both are equal, there will be no net development for your family. Last, if your enemy is very strong, it can change your direction, your destiny. And in this case, electron direction will be exactly opposite from copper to zinc. Current direction will be exactly opposite zinc to copper. Okay. In this case, zinc will be deposited and copper will dissolve. Exactly opposite of the first situation. Like when you are strong, you are taking care of everything and you are making it best. But when your enemy is having upper hand, it will go always against you. Everything is opposite. Example, in the normal situation, zinc used to dissolve and copper used to deposit. But When you change the potential, everything will become ulta. Okay. Okay. Same Daniel cell where you use zinc and copper is also known as galvanic cell. So, Barinder, what is galvanic cell? Same, where you use zinc and copper. So, in electrochemical cell, you have like any chemical you don't care. Ultimately, your chemical convert into electricity. In galvanic cell, it is a type of electrochemical cell where by using spontaneous process you produce electricity and mostly copper and zinc. It look more like Daniel cell. So galvanic cell is a type of electrochemical cell where you do same thing like convert your chemical into electricity. And same. Tuhina, what will happen to zinc in case of Daniel cell?
It'll get converted. I don't know, sir.
Oxidation.
Oxidation. Loss of
So
electron.
zinc convert into zinc 2 positive ion.
Yes, sir. And
Rayan,
then
what
two
will
electrons.
Yes, 2 electron. Loss of 2 electron. Rayan, what will happen to copper? Oxidation or reduction? Reduction. And what will be the conversion? Copper metal will be deposited. Copper 2 positive ion when interact with the 2 electron, it will convert into the copper metal. So copper will deposit and zinc will dissolve. So this is the same thing we discussed in the lineal cell. Exactly same thing. Okay. But through this, we are understanding two different parts. Okay, there is a electrode potential. Electrode potential is crucial to understand how the cell works. Okay. Chandana, in this case, when you understand electrode potential, tell me what do you mean by the electrode potential? Chandana, what do you mean by the electrode potential?
Sir, can you repeat the question?
What do you mean by electrode potential? Answer is it is the difference between potential difference between the electrode and its electrolyte. Sarah, what do you mean by electron and its electrolyte?
Sir,
Is it between
electrode
copper and zinc?
uh, between copper and zinc.
Hmm. Is it between copper and zinc?
Yeah, sir.
Answer is it is between the element and its own electrolyte. It means it is the potential difference between the zinc and zinc 2 positive ion. Okay.
Okay.
It is the difference between the zinc and zinc 2 positive ion.
Sure. Hello.
Hello. Yes.
Sir, if I got what you said, the definition about electrode potential, it
Yeah.
is not the difference. It is mainly the tendency of the electrode to lose or to gain electron.
Yes, it is.
This is what known as the
No,
electrode potential.
when you say ki tendency to lose electrons, so in that case you are talking about this oxidation. loss of electron. But here potential difference between the electrode and its own electrolyte.
Okay.
Yeah. The electrode potential is between the electrode and its own electrolyte, not with the copper. If you are comparing zinc metal compared with the zinc positive ion, two positive ion. Pratigya,
Yes, sir.
Pratigya, are you there?
हाँ सर
तो मुझे ये बताओ कि रिडक्शन पोटेंशियल को हम स्टैंडर्ड मानते हैं या ऑक्सीडेशन पोटेंशियल को? We will use reduction potential only mostly throughout the chapter. You will focus only on the reduction potential. Example, I told you key reduction potential of the copper is plus 0.24 volt, zinc 0.7 minus 0.76 volt. So what actually are talking about only reduction potential for both the elements. So most of time you will be having reduction potential. Brinder, if you want to correlate reduction potential with the oxidation potential, what will be the relation? Brinder,
yes
is
sir
this correct? Yes, it is. So I wrote reduction potential is equal to minus oxidation potential. What does it mean? Let's take example. If you have zinc reduction potential is, I will write Rp in the short. Rp oxidation potential OP. So if reduction potential of zinc is minus 0.76 volt, Ryan, what will be the oxidation potential of zinc?
So most probably it's 0.76.
Yes, plus sign. So in case of reduction potential, we are having negative 0.76. In oxidation potential, plus 0.76. So sign will become ulta. Okay. And I am going to write very important statement, though very easy to understand. If you have more reduction potential, there is greater tendency to reduce. More reduction potential, greater tendency to reduce. Interesting thing is, this is JE 2017 question. Though this is very basic statement still, as I mentioned, ki I will discuss all the 10 paper of JE which you wrote recently, all the 10 paper from all the ship. Every single question will discuss because it will be a great practice. So there I'll tell you ki how they frame the question. It will be only NCRT from past few years. So more reduction potential, greater tendency to reduce, JE 2017 question. And you know, more the value of reduction potential means it will easily undergo reduction. So Tuhina, example, if you take copper and silver, copper value given to you is 0.34 volt and Ag value is plus 0.80 volt. Copper value 0.34 volt. Ag value 0.80 volt. Tuhina,
Yes, sir.
which one will undergo reduction and oxidation?
Sir, AG.
Ag will undergo reduction. How do we know?
greater like greater
Yes,
reduction potential.
exactly. This is the point. Ki- That's why I said ki whenever you are considering oxidation and reduction, it is always comparative. Ki copper is reduced compared to zinc and oxidized compared to the silver. Sarah, if you are considering electrode potential, what will be the concentration in half cell? What will be concentration in electrode in half cell?
Not sure, I don't know.
Unity 1. It will be unity 1. That's why you will see they will write like zinc 1 molar. It will be like zinc 1 molar. What is the meaning? Ki molarity is 1, concentration is 1. Okay. And in electrochemical cell or galvanic cell or Daniel cell, more or less you are talking about the same stuff. Ki at anode there will be oxidation and at cathode there will be reduction.
Can
Jordan,
you just
will
zoom
it
out,
be
sir?
will it be same in case of electrolytic cell?
So
Will
your
it be
question
same
again, sir?
in case of electrochemical cell? Anode oxidation, cathode reduction. Is it same stuff in case of electrolytic cell?
No, sir. It's the alternate no.
It will be opposite. That's what you
Yes,
said.
sir. Yes, sir.
Okay. Rayan, what will be the charge on anode in case of electrochemical cell?
The electrochemical cell or electrolytic?
Electrochemical cell, anode and cathode.
Anode is negative,
Anode is negative,
cathode is positive.
cathode is positive. Okay. So, Jordan, when anode is negative, it undergo oxidation. Example, zinc convert into zinc 2 positive. Even in case of electrolytic cell, it will be same.
Oh, okay, sir.
But
I got confused with that
anode
part.
and cathode charge will different. So highlight this very important because it will be opposite in case of electrolytic cell.
So can you just zoom out once, sir? I was copying the upper part.
Yeah, just give me a minute. In case of electrolytic cell, your anode will be positive and cathode will be negative. Because in most of the syllabus, whether you consider gel electrophoresis, okay, whether you consider what are the chapter where you have electrolytic cell and cathode and anode, you have cathode is positive and anode is negative. Most of time when you study, whether it is in physics or chemistry or biology, always consider electrolytic cell because in general you provide current and then some chemical change happen. Best example, note it down. Jordan, you asked for this. Note it down. Gel electrophoresis. In case of gel electrophoresis, you have in your biotechnology chapter what happened. There you have cathode and anode. You have many places. I just forgot where exactly it is given
The
because I used to
structure
get
of atom,
which one, Sarah?
atomic structure.
Atomic structure. Yes, even in atomic structure, very good. Atomic structure, same stuff is given. He in gel electrophoresis at anode, you will have positive charge. At cathode, you will have negative charge. Same thing in the atomic structure chapter. In atomic structure, in Thomson model, you see how cathode ray electron movement and anode ray the movement of the positive charge happen. So there also anode is positive and cathode is negative. Yes, this is correct. Okay. So you have to always consider electrolytic cell and node positive. Cathode will be definitely ulta. In case of electrochemical, it will be again opposite, anode negative in electrochemical cell and node negative in electrochemical cell. But interesting part is still in case of electrolytic cell, even in the electrolytic cell, anode will have oxidation and cathode will still have reduction. Tell me, any doubts? Pratigya, tell me what is the difference between the electrode potential and cell potential?
याद नहीं सर
याद नहीं. Barinder, what is the difference between the electrode potential and cell potential? Chandana, what is the difference between electrode potential and cell potential?
No, sir, I'm not sure.
Jordan, difference between electrode potential and cell potential.
I don't remember. So
Rayan, what is the difference between these two?
Yes, sir. The electrode potential is what you say, the difference between the electrode potential of the cell,
Yes.
of the electrochemical cell, but
Mhm.
cell potential is the difference between electrode potential of the half cell.
You made it ulta. The electrode potential is the potential difference between the electrode, a given metal, and its electrolyte. Like you take zinc and zinc 2 positive, potential difference will be electrode potential. Cell potential is the potential difference between the two electrode, means between copper and zinc. Got the difference, Ryan?
Okay, sir.
Between two electrode, not with electrolyte. Example, in case of electrode potential, either you take only zinc, then you are considering zinc and zinc 2 positive ion, or you are considering only copper, where you consider copper 2 positive to copper ion. Correct? So this is electrode potential. Cell potential means between zinc and copper. Okay? Between zinc and copper is the cell potential. That's why in cell potential, E cell, you write E anode, E cathode, like that. E cathode minus E anode, right? For E cell. So this is really, really important, because see, you will be able to solve most of the question. But if nuance they are looking for, ki very small, subtle difference between cell potential and electrode potential, you might make mistake. Right? Next, Sarah, what is the difference between EMF and electrode potential or cell potential, let's take. What is the difference between the potential difference and EMF?
No, I don't know. Not sure.
So, Hina,
I
difference
don't know,
between the
sir.
potential difference and EMF. Answer is EMF is the potential difference when there is no current, maximum value. And potential difference is usually less than EMF. You have this in your current electricity chapter. In current electricity, I taught this point. EMF is the maximum value. Potential difference is always either equal to EMF or less than EMF. It's like ki you. I'll give you example. When you pay fee, so you pay for full year for 365
No,
days.
sir.
Nice.
No.
सर मेरी वॉइस क्लास में सुनाई दे रही है
हाँ बिल्कुल सुनाई दे रही है
तो सर नहीं
अरे just an example.
प्लीज सर
I am just this is instant. This is not pre-planned. Instantly I got this best idea. Example, guys. You pay for 365 days. Like when you pay yearly or monthly. Do you get all 365 days class?
Never.
नहीं सर सर बदनाम क्यों कर रहे हो सर
No. It's just an example. So this payment of 365 days is your EMF. The actual class you get is your potential difference. Tell me, guys, will you forget this example? Rayan?
नहीं सर
So this EMF is like ideal condition when there is no current, guys. When there is no current, there will be maximum potential difference you can imagine. EMF is a maximum potential difference. Okay, maximum value of potential difference. So potential difference usually have value less than EMF because this is ideal condition. When you buy a battery, maybe it will be written it will give you 2 volt, but in reality you never get 2 volt. You will get 1.5 or 1.8. So that is real potential difference. Okay. And when you explain this cell reaction, you combine the reaction together. Example, write cell reaction for Ag and copper. You write any cell reaction. Example, when copper solid will react with the Ag positive 2 molecule, and here I am writing AQ. Pratigya, what does it mean AQ? Copper solid and Ag AQ. Aqueous solution. That's why you have the positive charge. Okay. So here copper in the solid form will convert into the aqueous solution and copper will convert into copper 2 positive ion. And your Ag2 positive convert into Ag. Reduction. So you can see because reduction potential of Ag is more, so it undergo reduction, and reduction potential of copper convert into copper 2 positive, so this is oxidation. Same thing you can write in the form of cathode and anode. So tell me, Barinder, what will happen at cathode? Oxidation or reduction?
So oxidation.
Cathode is reduction, and this is universal whether you take electrolytic cell or galvanic cell. So if this is the situation, Chandana, what will be the reaction at cathode if you consider copper and silver? Cathode have reduction out of copper and silver, which will undergo reduction.
Sir, silver.
Silver. So it means 2 Ag positive will react with the 2 electron, gain of electron reduction, and convert into 2 Ag. Correct? So if you know cathode will undergo reduction, means anode will have oxidation. And if anode have oxidation, then your copper will undergo oxidation by losing electron. Copper convert into copper 2 positive by losing 2 electron. So, Jordan, how to represent the cell? Jordan, how to represent the cell?
So first you have to represent the reduction, that is
First, oxidation.
okay, oxidation first.
So, oxidation you will write first in an equation, oxidation first. Okay, you will write reaction like this. You know, in this case, oxidation means copper. So, your copper in the solid form convert into copper into 2 positive aqueous form. Okay.
Yes, sir.
So, gap between copper and copper 2 positive will be shown by a line. That is telling you basically electrode potential. Correct?
So the thing that line has a name, no, so some phase something. I forgot.
No,
Something like phase boundary. Okay, sir. I'm mixing up then.
maybe. Then reduction later, you know silver undergo reduction. So how will you write this whole reaction? Copper in the solid form will convert into copper 2 positive aqueous
Two
form.
positive aqueous form, double
Then there
lines,
will be double line. Double line means salt bridge.
salt bridge.
You are talking about this?
No, sir. The single lines, I remember reading it somewhere. They called it some phase boundaries in some reference notebook.
Hmm. And here, this Ag positive
Reduction.
aqueous will undergo reduction and Ag positive will convert into Ag. Got it. Got it? This is the cell representation. Hmm. Sarah, what is the formula for electrode potential of this cell? Cell potential, basically. Sarah, what will be the cell potential E cell value? Cell potential means E cell.
Uh, cathode minus anode.
Cathode minus anode. By the way, you will get this question. How many of you wrote this JEE exam? Tuhina, you wrote.
Yes, sir. Sir, the
So
bell
many.
rang. Can I leave and join?
Yeah, sure.
Thank you, sir.
Yeah. Chandana.
Yes, sir.
So you got question from the this chapter electrochemistry, cathode anode E cell.
Yes, sir.
There is always question in every exam from this. And the best part is you never mistake, like you never make mistake out of that. Rayan, did you get question from the electrochemistry from the E cell, cathode anode, something like that?
याद तो नहीं पर आया तो होगा.
हाँ. So E cell formula is cathode minus anode. Why I said ki you will never make mistake? Because value is always positive.
But sir, हमेशा cathode minus anode नहीं होता है.
नहीं, we are talking about the electrochemical cell.
No, sir, but in electrochemical cell only for the reduction potential and the normal, if both are reduction potential or one is reduction potential and oxidation potential.
Then
If both are oxidation potential, then the opposite happens.
correct. So that's why I wrote before कि in this whole chapter we will consider only reduction potential. Whenever you have oxidation potential and you want to convert into the reduction, then take the minus sign into consideration, right? If oxidation potential is given, let's take 0.55. This is the oxidation potential. Then reduction potential will be minus 0.55. Because if you are right, if we don't consider reduction potential, there will be too much confusion, and because of the sign convention, there will be issue. Got it? Priyan, any issue?
No, sir.
So E cell cathode is kept on the right hand side. So can be also written as E on the right hand side minus E on the left hand side. Okay. Example in this case, right hand side we have Ag and Ag have cathode and cathode have reduction. So E where Ag positive convert into Ag minus E copper convert into copper 2 positive. Is this correct? Pratigya, is this correct? Ag positive convert into Ag, and for E you have copper convert into copper 2 positive. Pratigya,
Yes, sir, correct. Sir.
this is wrong. Why? Because as Rayan you mentioned, we will consider only reduction potential, only then this is applicable. Here copper is undergoing oxidation. Okay, so
So can
not
you explain it again? So I'm
yes,
lost.
yes.
सर
You are lost.
ऑक्सीडेशन एनोड में होता है
नहीं, एनोड पे ऑक्सीडेशन होता है, but even for the oxidation you have to take the value of the reduction potential. So consider
सर आई एम कंफ्यूजिंग
consider only reduction potential. इसलिए अब यहाँ पे confusion है.
If करेंगे, then it would be understood better, sir.
Yes. So guys, what I am saying कि यहाँ पे whatever question you will solve in electrochemistry in E cell, like cell potential, you have to take only reduction potential value, only reduction. What I wrote on the screen, this is for copper, this oxidation is given, so this is wrong. You have to take reduction potential only. So that's why you have to write copper to positive convert into copper. Jordan and Pratigya, any doubt? Only reduction potential.
So this whole chapter just think about reduction potential, not even
Yes.
about oxidation
Yes.
potential.
So
Okay,
if
so
oxidation potential is given, then convert into reduction potential by negative sign. If oxidation potential is given, convert into reduction potential by taking negative sign. Okay, example. If you take for copper, when copper convert into copper 2 positive, Barinder, is this oxidation or reduction? Copper convert into copper 2 positive. Oxidation. And this oxidation potential value of the copper is minus 0.34 volt. So Barinder, tell me, what will be the reduction potential of the copper? Barinder, what will be the reduction potential of the copper? Any doubt? Barinder, are you there? Is Barinder there? She is trying to speak, but she can't. Okay. So everybody understood from this? Here oxidation potential value was given, and you will confuse. That's why I know in future you will have more confusion based on the oxidation potential, reduction potential. Sum it up in one line. For E cell, always use reduction potential only. And if oxidation is given, convert into reduction by negatives. Jordan and Pratigya, any doubt?
No, sir.
No, sir.
Right. And I mentioned one statement: ki you will never make mistake in this topic. Why? Because E, e cell is always positive. E cell is always positive. Even if you make mistake of the sign, still you should always get the positive value. Okay, let me give you example. You have two element Ag and copper. Ag is 0.80 volt and copper for Ag reduction potential is given 0.80 volt, and for copper value is given minus 0.34 volt oxidation potential. Calculate E cell, guys. Calculate E cell.
Sir, 1.14.
1.14. So there are two possibilities. Either you will take 0.80 minus 0.34 and it will become 80 minus 34, 46. So 0.46 volt. This is one possibility. Second possibility, you will add them, correct, and it will become 0.80 plus 34, 114, 1.14 volt. Which one will be correct? Tuhina, are you there?
No, sir, she's not here.
Jordan, what should be the answer? 0.46 or 1.14?
So, 1.14.
1.14. Sarah, 46 or 114? Question is, your Ag reduction potential is
Sir,
0.80 volt. Yes, Jordan.
the formula states that RP minus reduction potential minus what is oxidation potential, but the minus and the minus basically make it a positive no, so therefore it will be 1.14.
Okay. So in that case, what is happening? If you solve, you know E cell value is equal to E at cathode minus E at anode. Correct? Reduction minus oxidation. Your reduction value should be like for Ag 0.80 minus what is the oxidation potential? 0.34. So what will be the answer? 0.46. Correct? Any doubt?
No, sir.
So, but
And
then it's minus 0.34 no.
oxidation potential.
Oh, okay, yes, understood, sir.
Oxidation potential I gave, not reduction potential.
Okay, I think that's where I went wrong.
Yes. Okay. That's why just I'll finish Nernst equation, one of the most tricky topic, and after that we'll solve question on this topic. Anybody have doubt till here?
सर
Yes.
सर अगर
Continue.
Ag का माइनस ऑक्सीजन पोटेंशियल लेंगे
तो माइनस ऑक्सीडेशन पोटेंशियल लेंगे तो उसको रिडक्शन पोटेंशियल में कन्वर्ट कर लेंगे।
नहीं मैं बोल रही थी कि -0.80
हम्म
then -0.34
हम्म
तो ये तो नेगेटिव में आ जाता।
तो नेगेटिव में आ जाता। नहीं नहीं, वही तो है ना कि अगर तुम बाई मिस्टेक, इफ बाई मिस्टेक यू टेक Ag एज माइनस साइन, then you can never have the negative value. You are getting my point? By mistake, if you are taking Ag as minus 0.80 volt, so your value will overall become negative, which is not possible. It means you are making mistake. That's why I'm telling you, in this topic you can never make mistake because value will be always positive. Understood?
Okay, sir.
Huh.
Yeah.
Yes, Rayan, what you wrote in your notes is correct. And that's why to avoid three formula, we are focusing only on one formula, ki in reduction potential, cathode minus anode. Got it, Rayan? Huh. So all the three formula what you have sent is correct. But I also know once you finish the full syllabus, you will have a lot of confusion here. To avoid that, we are using only one formula, but only in the form of reduction potential. And that's why, guys, in copper, first you have to convert into the reduction potential because value is given in oxidation potential. How to convert? Reduction potential is minus of the oxidation potential. So last topic, and then we'll solve question. Minimum 5-10 question from this topic will solve from PYQs. How to measure the electrode potential? Method is this, cell potential. How to measure the electrode potential? Sarah. As of now, like we can easily measure the cell potential. How? Cathode minus anode. Done. In reduction potential. Cathode minus anode in reduction potential. How to measure electrode potential? Sarah.
It's a standard hydrogen electrode. I
Yes.
don't remember.
Standard hydrogen. So guys, remember, you can easily do your cell potential by comparing the two elements. How to get for the individual element? Answer is standard hydrogen potential.
So till wherever you've done, can you send the PDF in a group?
Yes, I will explain what you missed. Just tell me what you missed. Look at this.
So a little
Did you
more
miss
up, I think.
Did you miss everything what is visible in the screen?
Yes, sir.
Did you
Electromotive was there. Till there I was there.
so cell reaction?
Yes, sir.
It is one example between the copper and Ag. Which one will undergo oxidation and reduction?
Yes, sir.
Ag reduction potential is more. Ag reduction potential is more. That's why it will undergo reduction.
Yes, sir.
Copper value is less, so oxidation.
Yes, sir.
Whenever we represent the cell, you can write later, but just understand. Whenever you represent the cell, first you write oxidation reaction, and then you write reduction process. And between these two electrode potential, you have salt bridge double line.
Yes, sir.
Whenever you calculate cell potential, you know cell potential means between the two element copper, zinc, copper or Ag or any other. So there usually teacher go for the three formula which is correct.
Yes, sir.
But I also know when I used to do this, I always had confusion. So to reduce it, I have only one point. Formula is E cell is cathode minus anode, and you will only consider reduction potential. You will consider only reduction potential. Got it?
Yes,
Or
sir.
in electrochemical cell, cathode is present on the right hand side and anode is present on left hand side around your salt bridge. So you can write right minus left, same thing. And you never make mistake in this question because your value of cell potential should be always positive. By mistake, if you change the sign, you will get negative value, which is wrong. Even if you put Ag negative and copper positive, still it will be negative. Practically not possible.
Yes,
Understood,
sir.
guys? See, you can make three type of mistake. You take Ag negative, copper positive. This is wrong because your overall value will be negative. Second possibility, you can take this. What was the value? Yeah, so Ag negative and copper positive. If you take like that, still it will be like negative value and you can compare. So you should get only positive value, nothing else. Let me know if you have any question around this topic. Got it, guys? Rayan, why we are considering hydrogen for the electrode potential measurement? Why do we consider only hydrogen for the electrode potential measurement?
Not sure.
Because for hydrogen, your reduction potential value will be zero. Even for the oxidation potential, it will be zero. Whether you take oxidation potential or reduction potential, it will be zero, and zero is your standard. Based on that, you can compare whether it is negative value or positive value. Jordan, is this zero potential there only for the 25 degrees Celsius temperature or all temperature?
It's
This
only
is
there for
first
25.
level question. This reduction potential of the hydrogen will be zero at all the temperature. Tell me, was it there in your notes, Ryan? At, at all the temperature. Doesn't matter you have 0 degrees Celsius, 25 degrees Celsius, or 50 degrees Celsius. Why? Because temperature never change electron potential. Because temperature never change the electrode potential of the element. Okay, that's why we study standard hydrogen electrode for the comparison. You can compare copper with the hydrogen because copper value is positive, hydrogen is zero. Overall, it will be positive. Okay, but in NEET, they don't ask much question. Only possible question is what is the comparative element for the electrode potential hydrogen? What is the value? Zero. Is it zero at specific temperature or all temperature? All temperature. Okay. For board, they can ask question for 3 marks where you have to draw a diagram. You have to write key. You use platinum electrode, and this platinum electrode will be covered with the platinum coat. So, guys, are you getting a lot of noise or is it manageable?
Manageable.
Manageable, sir.
Okay. Okay. So let me know if you feel too much. Let me tell everyone. So So if you see here, you will use platinum electrode, and this platinum electrode is coated with the platinum black element only again, coated with platinum black. So these kind of thing asked in the board, not in the NEET. Never asked. That is the maximum thing we can expect in the NEET. Okay. हाँ सही बात है यार. Move to the Nernst equation. One of the most popular equation, and I think this is the one equation where some people, not all, feel scared कि अरे यार ये भी करनी पड़ेगी. We have to do this. How many of you have fear from the Nernst equation? Tuhina
Me,
or
sir.
Sir, I don't know the chapter, so I can't say anything.
Okay. Yes, Ryan. सही बात है. Makes sense. हाँ सारा
Fear नहीं, लेकिन बहुत घटिया लगता है,
बहुत
अजीब.
घटिया लगता है. शकल देखते ही
हाँ
मूड खराब हो जाता है. Nernst. Very bad. It is.
हाँ सर, मतलब करने का याद, मतलब मन नहीं हो.
करने का मन नहीं होता. Okay. Sarah Anthony.
Sir, I don't remember.
This is the top level aura.
तो अगर
Jordan.
फिजिक्स होता तो आई विल
हाँ.
मैनेज.
But chemistry, it's horrible, pathetic.
यस सर.
Jordan, Roland,
No, sir, I don't like it at all, not one bit.
you don't like it.
No, sir.
You don't like Nernst name or you don't like Nernst equation?
Nernst's name is fine. Nernst equation is chi. Can't do
Chi,
it.
chi. Okay.
Yeah, chi. This chi.
Chandana,
Yes sir, I have some issue in this.
you have some issue. You don't like it, or you have personal enmity with this.
Yes sir, I don't like this.
You don't like this. Then Barinder Kaur, मजा आता है Nernst equation देख के?
Yes, sir.
मजा आता है?
Yes.
ऐसा भी क्या फील ले रही हो कि यार Nernst equation आ गया, अब तो नीट में सिलेक्शन पक्का, डॉक्टर बन गई मैं. नहीं नहीं एक्चुअली
इसके क्वेश्चन अच्छे लगते हैं.
क्वेश्चन अच्छे लगते हैं.
Yes.
So the good thing is कि Nernst equation is easy, and uh, best or worst part is you always get question from the Nernst equation, directly or indirectly. Directly or indirectly, you always get question from the Nernst equation in your competitive exam, both in NEET and JEE. And tell me, guys, how many of you have seen this Nernst equation? Okay, like Chandana, did you see Nernst equation question in the recent exam, like in your JEE exam?
No sir.
It was not there.
No, sir.
I'll check today and then we'll see. Key example: if you take any equation, you take any metal that have some charge. When it gains some electron, it will convert into the pure metal. Aqueous metal will convert into the pure metal. Is it oxidation or reduction? Aqueous metal in the ionic form convert into the pure metal. It is oxidation or reduction? Barinder. Oxidation or reduction? Barinder. This is
Sir,
reduction. Reduction. So there are two things. If you calculate your cell potential, then you consider Nernst equation M with some positive charge convert into M, reduction. That's why the reason why I consider only reduction potential and I don't teach anything else, because in Nernst equation you use reduction potential and you will get confused. Second, you will use term E naught. And E naught, what is the meaning of E naught, Rayan?
Hello, yes, sir.
What is
Standard one.
E naught is standard reduction potential.
Standard reduction.
So what is the difference between reduction potential and standard reduction potential?
Reduction potential होता standard मतलब उसमें standard होता.
वाह, you are best. कोई नोबेल प्राइज दे दें छोटा मोटा तुम्हें. Answer is, in standard reduction potential we compare with the hydrogen. In standard reduction potential we compare with the hydrogen always. That's why we call it as standard, because it is always compared with the hydrogen. In this case, if you are considering metal, pure metal in the solid form, you will always consider concentration unity 1. Concentration for the solid metal will be unity, it will be 1 value. And if you know all of this, Nernst equation will be so the value will be E cell will be equal to E naught cell minus RT by NF natural log product is metal by reactant is your ion. You wrote complete equation. E cell. What is E cell? Your E Mn positive to M is your E cell. Cell potential. What is E naught cell? Standard cell potential compared to the hydrogen. And whatever is given on your right hand side, you will write in the M above and Mn below. In other form.
सर
Yes.
सर आप एक बार बता दें कि log 1 2 3 सब है.
Log 1 2 3. How many of you feel difficulty in log, guys?
log 1 log 2 वैसे ही.
How many of you feel difficulty in log?
Me, sir.
Okay. NF, natural log, basically product by reactant. In Nernst equation, when you write natural log, it is product by reactant. For remaining people, I recently taught this log form, right?
Yes, sir.
Yes. So still I'll cover once again. This is the Nernst equation where E cell is equal to E naught cell minus RTNF natural log product by reactant. That's all. Product by reactant, product by reactant, product by reactant. So do one thing. Write this Nernst equation 5 times right now and send me. Like send in the group and Rayan, you send me directly.
Yes.
Write Nernst equation 5 times. Why? Because this is one of the most important equation of the full chapter. And we will solve a lot of questions from this today only.
So when
You
you
will. Yes, Tuhina?
so can you also send the PDF in the group?
Yes. Rayan, I am adding you in the group so you can assess all the content. Okay.
Okay, sir.
Mm.
तो डायरेक्ट वैल्यूज डाल के नहीं निकाल सकते आरटीएनएफ नहीं लिख
Nikal. Okay. That also makes sense, guys. Wait, I will add
तो वो
one more. वही ज्यादा easy रहेगा and we use only that part. Guys, E cell is equal to, in the simplest form, E naught cell minus 0.06 divided by N log product by reactor. Okay, because let me ask question. Chandana, what is this F? Is this F unit of capacitance? Right, both equation like three times. Yes, guys, I want to show you Nernst once. Nernst. See this. This is the same guy. So what would you say about Nernst? Jordan?
So
The
there's a
Jordan
network
would hate him
issue.
more now.
Yeah. You want to
Huh?
see Nernst person?
Yes.
Look at this guy.
He's very grumpy.
He's very grumpy.
That's so cute.
So
So cute. It
so
look it look like
sir,
he
sir,
is
sir, sir,
also
sir, sir,
frustrated from
sir.
his own equation.
Humpty Dumpty and Adolf Hitler if they had a son.
Jordan, you don't say stuff like that, Jordan.
It's a fact.
We don't care, guys. It's just he look like he's really frustrated from his life, from his own equation. That's why
He
he
hates the
want to.
world. He looks like that.
One person. When he was frustrated by his own equation, then why did he discover it?
Very good question, but there's no logic in fun. He was born in 1864 and died in 41. Wow, 77 years.
So
So
did the people before like before like 1950, did they not know how to smile at all?
no, I
Like,
think they were not used to the camera, and people must have not told them ki okay, ki, you need to smile. They're like, what is this equipment?
no,
Probably
like
I
anyone
am
before
looking at.
1950s, like my grandparents' wedding also, they didn't smile.
They didn't smile in their own
Yeah, I
wedding.
have the wedding pictures. They all didn't smile. Like everyone in the family.
You
10 years
send
later,
me.
and
You
I'll
send
search
me.
and I'll show. I'll search and I'll show. It's too funny.
Is it?
Yeah, they're all just standing there looking like ghosts, black and white picture it is. And then for the 50th wedding anniversary, same people have come again, sir. Some of them may have died, some of them are still alive. They have come now in the 50th anniversary picture, they're all smiling.
Same people.
Same people. I mean, like
That is the.
50% gone down under, 50% is still surviving.
Ah,
So, yeah. But you should see, sir, they're all smiling and then they're smiling.
they're smiling and smiling
No,
after
they're
50 years.
smiling first. They're smiling in the last picture, not in the first.
Okay, maybe. We don't know. So all of you send in the group these two equation. We will focus more on the second equation because here F value is fixed. Rayan, what is the F value?
It's Faraday, that is 96,500.
Is this capacitance unit? This is correct, 96,500. What?
Yes, sir.
No, it is charge unit. 1 Faraday is equal to 96,500 coulomb. See, right? 96,500 coulomb. R value is fixed. Temperature we will calculate at a given, we will calculate E cell at a given temperature, and then you can calculate the value. So what is the temperature in this situation?
298 Kelvin.
Yes,
That is the snow.
it will be 298 Kelvin. This is standard. So guys, quickly send me this equation because we have to solve many questions using this equation. Many
So
means
can you
many.
just show the whole Nernst topic once again, sir? Just take a
Sir,
screenshot and
can you
create it.
send the PDF, sir?
I sent PDF in the group.
I
Just
didn't get it, sir. Oh, wait. No, man.
discrimination with Tuhina Prabhu.
Sorry, sir. Sorry, sir.
You are discriminating me. No, not
Sir,
discrimination.
not discrimination, sir.
This is
I'm
not
bullying you,
discrimination.
sir.
You are
False
ruling me.
accusation.
Sir, no, sir. I'm very power.
You are very powerful.
She said Pavam, sir.
Power, sir.
She's not Pavam at all.
Power means
It's like what, Bechara. I have to explain this to now all the Hindi speaking people in
naive.
my class.
Naive.
Naive or Bechara? Basically that.
Naive, bichara. Bichari.
Sorry,
Whatever, something. I don't know much Hindi,
Jordan. Her
okay?
Hindi is better than you.
I agree on that point, so I just have to explain to some people because here I say Pavam or Papa. They'll be like, why you talk about father?
Huh.
And so then I have to explain, oh, back in Bangalore used to say this.
Okay. Yeah, I got from Sara Chandana. All of you make it fast. So you know you
Sir,
can
I'll
leave
send
any.
after class, sir.
You okay?
Please,
But
sir.
you
I
have to
1 minute,
request
send
this.
sir.
separately. Jordan, Barinder, and Ryan, you send in the group.
1 minute, I'll just copy it and I'll send it.
Hmm.
So you want full class notes?
No. Only this Nernst equation because you get most questions from this.
Yes, sir, 1 minute.
Huh. Pratigya. Okay. In this topic, you need
So,
log
so
value.
once again, can you just show it? I'll take a screenshot now.
Take screenshot. I will explain this log value again because you might need in
Done,
like
sir.
difficult question of this topic. Done, Jordan?
I took a screenshot, I just have to finish writing.
Make it fast. Ryan, did you send in the group? Um, आज तक पहुंच जाएगा. So, Pratigya, Chandana, Sara. Make it fast, Jordan. So, what happened? What is this n value? N value is the number of electron transfer. Number of electron transferred. So, example, if you take zinc, you know zinc will react with the copper 2 positive and it will convert into the copper and zinc 2 positive. You know, ultimately 2 electron is transferred from the zinc to copper. Ultimately, it will transfer from zinc to copper. 1, 2, 3, 4, 5. Rayan, 0.0591 is the correct value, but for NEET exam, we don't need this.
हाँ सर, पर लिखते वक्त यही लिखना होता है, पर कैलकुलेट करते वक्त उस वैल्यू को डाल के कैलकुलेट करना होता है।
यही तो फर्क है बोर्ड के बच्चों में और नीट के बच्चों में, रह गए ना पीछे।
सर अभी मतलब क्योंकि वो पीडीएफ वगैरह सब चल रहे थे तो यही आदत है लिखने की।
हाँ, 0.0591 is the correct value. Example, I taught them recently chemical kinetic. So people write 0.693, but I always write 0.7 because for NEET that's what we need.
I
Otherwise,
sent it to you.
yes, Jordan. 1, 2, 3. So in this case, what you can see, zinc will lose 2 electron while zinc is converting into zinc 2 positive. There are 2 electron lost by zinc that will move to the copper. So 2 electron are transferred. In this case, your n value will be 2. Remember, not the charge on a given atom. It will be the number of electron transferred. Number of electron transferred. Number of electron transferred. Okay. Next. What is the name? Chandana. What is the concentration of product by concentration of reactant? Chandana, what is the concentration of product by concentration of reactant?
Sir, is it equilibrium constantly?
Very good. This will be equilibrium constant, and this is very important in your chemical equilibrium. So I will just go use some content to explain this Kc. Kc is equilibrium constant when you are using concentration. When you are using concentration. What is this bracket mean? Active mass. What this bracket means? Active mass. And this active mass is same almost like concentration, which symbol is square bracket. Okay. If you take pure solid or liquid, pure liquid, in this case, your concentration value will be equal to 1 or unity because it is not changing with the time. Your concentration value will remain same because it will not change with the time. So active mass will be like concentration and bracket like this. And for pure solid and pure liquid, this. Now tell me guys, give me a minute. Hello. हाँ का कविता हाँ हाँ मौसी कितना कान माँ आवेगी के आवा है मौसी भरला लट्टू बंद कर दीजिए राड राड बंद कर दीजिए राड और लट्टू बंद कर दीजिए हाँ ठीक है मौसी So, प्रतिज्ञा Sara. What happened to Pratigya and Sara? Yeah, so guys, I think it's been almost 2 hours. This will be the last topic for us to discuss, and then we'll discuss few questions. Okay. Move to the part. In case of your chemical equilibrium, it is given कि whenever you take square bracket, it means active mass, or you can call it concentration. For pure solid and liquid, it is 1. And if you write any equation, A convert into B. So in that situation, there will be two parts. One, for the forward reaction, reactant to product. Example, R convert into P. R means reactant, P means product. So it is forward reaction. And equilibrium constant for this forward reaction will be Kf. When product convert into reactant, then it equilibrium constant will be Kb, backward reaction. Okay, backward reaction. And what is the meaning of equilibrium, Rayan? What is the meaning of equilibrium? And what is the difference between the Kc and Qc?
सर वो 11th का था सर, अभी रिवाइज नहीं किया है.
So please, sir, don't expect this, sir. 11th portion, sir. Yes,
हाँ सर.
that is true. But equilibrium in general we have in whole physics, chemistry, and biology. In physics, equilibrium in case of rotation means net force is zero, net torque is zero. Example, you have stable equilibrium, unstable equilibrium in your electrostatic. Stable
सर
equilibrium.
पर आपने केमिस्ट्री का पूछा है शायद.
Sorry, I apologize. So, nice, it remains same. In case of chemistry, when we say equilibrium,
सिस्टम में टॉर्क कहाँ से आया?
मैं गलती है, मेरी गलती है, मैं पापी हूँ. मैंने कैसे पूछ दिया ये सवाल? So, no, I actually I'm trying to correlate physics, chemistry, and biology together. In physics, equilibrium is more about the minimum energy, maximum stability, or net force, net torque zero. In chemistry, equilibrium means forward and reverse reaction is same. Example, you keep dissolving sugar in water. So the moment it will start settling down, so this will be the equilibrium situation. So equilibrium means your forward speed will be equal to your backward speed. Your forward speed will be equal to your backward speed. So Hina, how to write forward speed rate of the forward reaction?
Huh? I didn't understand, sir.
Are you eating?
No, sir. No, I
Okay.
didn't understand what you mean by how to write forward reaction.
Like for any given reaction, reactant converting into product. So
Product
how
by reactant, right?
no, what
Eh?
do you do in the chemical kinetic?
Oh, the concentration.
Exactly. So
Yes, sir.
it will be Kf. K is rate constant. F for forward reaction, and your reactant value is R. Correct? For forward reaction, Sarah, what will be the rate? Sorry, backward reaction, what will be the rate?
The KB
Kb.
P in bracket.
Why P? Because it's like P is converting into R. In this situation, P is like your reactant. Understood? That's why this. At equilibrium, forward rate of reaction will be equal to backward rate of reaction. It means your Kf of and R will be equal to Kb by P. So Kf by Kb will be equal to product by reactant. And this is what equal to Kc, equilibrium constant for concentration. Okay? Concentration. Kc will be equal to Kf by Kb equal to product by reactant. Understood? And that's why for this Nernst equation, instead of your product by reactant, what you can write, Jordan?
So, could you repeat the question again? I was writing.
For Nernst equation, your product by reactant, instead of that, what you can write? Kc.
KC, yes, sir.
So if you modify your Nernst equation, can you say your E cell, your E cell will be equal to E naught cell minus 0.06 by n log, instead of product by reactant, can we write Kc directly?
Yes, sir.
And if you can write this, Pratigya, what value will be zero at equilibrium? In chemical equilibrium. At equilibrium, which value will be zero?
Kc value.
E cell value will be zero at equilibrium because your cathode and anode value will be exactly same. Okay, so net will be zero at the equilibrium. E cell will be zero at equilibrium. E cell will be zero at equilibrium. And if this is the situation, Barinder, what will be E naught cell value? Any doubt, guys?
No, sir.
Okay, done. So this is all about the E cell, E naught cell. Remember, E naught means standard, E cell general, like reduction potential. You will consider always. If you consider Gibbs free energy, okay, I asked this question, Ryan. What is the difference between Kc and Qc? Remember, Qc you can calculate at any moment, and Kc only for the equilibrium. Correct?
फिर से रिपीट करेंगे.
Kc, equilibrium constant, is considered only for the equilibrium condition. Kc for equilibrium condition only. Kc only for equilibrium condition. Only when you have equilibrium, you can apply Kc, because this is very rare. Whether you are dissolving sugar in water, it will be less than the saturation or more than saturation or more than equilibrium, right?
Yes, sir.
Like when you are earning money, you will earn less than what you need or you will earn more than what you need. There will be rare instance ki you are earning 10 rupees in a day and you are spending 10 rupees in a day. Like your expenses are 10 and your income is 10. This is very rare condition. So Kc is only for the equilibrium. At any other moment in your life, whether you are in the positive situation, you have saving or you have loans, you will use Qc value. Reaction coefficient Qc is the reaction coefficient. Reaction
Okay,
coefficient.
sir.
Okay. So because NEET asks very frequent question from this topic, Kc and Qc, and based on these two value, you can easily tell whether a reaction is will happen in the forward direction or backward direction or equilibrium. Got it, guys? Who will tell me? Pratigya, what is Gibbs free energy? What is the simplest meaning of Gibbs free energy?
Combination of all energy.
Yes, all energy.
Sum of all energy.
Sum of all energy. Uh, sum of all energy, you can call it as total energy. So, gives free energy is the net energy released from a reaction which is useful. Example, you eat, like you have your dinner. From dinner, you get 2000 kilocalorie energy. From food, you get 2000 kilocalorie energy. But you spend 500 kilocalorie for the absorption and digestion. 5 kilocalorie for absorption and digestion. 300, 500. 300 you get, you waste in the form of the excretory product or digestive waste. Okay. Tell me what will be your net energy which will be useful for us to improve our body, to maintain the body, to repair the body. Total energy you get 2000. 500 for digestion absorption. 300 for wastage excretion and all. What will be the net value which will be useful for us? Anybody can answer. Jordan,
I'm not sure.
Rayan, Tuhina.
Sir, I don't understand what's going on, sir. I have to rewatch recording.
Okay. You don't have any idea what is going. Actually,
Sir,
we
I
need
don't know
to.
why I'm so confused.
It's okay. It's okay. I will give a quick revision. So,
No, sir, you can just send the recording. I'll just redo it.
okay. So, Tara,
Not sure.
Tara,
Not sure, sir. Not sure.
Chandana,
Sir, can you repeat the question?
my question is you consume 200 joule energy. Let's take in the simple form 200 joule. 500 you invest in the digestion and absorption. 300 you waste in the form of excretion or waste product. What will be the net energy that will be useful for our body? 1200. 1200. Total energy we got 2000. 500 for digestion and absorption. 300 for waste. What is the remaining that will help to maintain our body or grow our body? Only 1200 will be useful energy. That useful energy is known as Gibbs free energy. Tell me, any doubt?
No.
Exactly. So this is gives free energy, useful work that we can utilize for our body. Useful energy is gives free energy. So write in the simplest form, useful energy. What is the spelling of useful? USEFUL. Okay. So in this case, if you calculate delta G value, it will be minus NFE cell. If you calculate G naught value, it will be minus NFE naught cell. It depends whether you want to calculate normal situation or standard condition. Okay. And same delta G naught value is also equal to minus RT natural log K. Very, 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 very important. And that's the end of the theory. I will take only 15 minutes for the question. So, what is your job? I am sending this PDF in the group. Take 5 minute break, don't do anything. Next 10 minutes to revise the notes. Go through it, ask your question. I will have dinner till then. And
So my dad called me. I'll join the meeting in 15 minutes, sir.
yeah, sure. No issue.
Thank you, sir.
Okay. So,
Thank you, sir.
hmm. Yes, Chandana. Electrode potential for aluminium, silver, potassium, and chromium. Imagine all potential given are reduction potential. All value are given under reduction potential. You have to identify the reducing power of the metal. Chandan,
Yes, sir.
what is your answer? Chandana.
Yes, sir. Answer.
Hmm.
Sir, is it option B?
Option A. Because you have to see ki reducing power means reduction. The more positive value, more reduction. And even in general, silver have very high uh, reducing potential. So only in one option you have easy maximum value. Wait. Reducing
Yes, sir.
power, no? Not reduction. Wait. Reducing power, not reduction. So, if this will be minimum, why? Because your reduction, any element that undergo reduction is very good oxidizing agent. Very good oxidizing agent. And same way, if any element undergo oxidation, then it is a reducing agent. It is not asking reduction but reducing agent. So asking for which element will undergo oxidation. So B is correct. Chandana. Everybody understood, or should I explain this again?
Yes, sir. Can you explain?
Sure.
So what are we
So
doing now, sir?
we are starting question.
Okay, sir.
Problem. So first you have to understand, Sarah, question number 1. Ki if any element undergo oxidation, it will cause reduction of the other element. It will cause reduction of other. So it is reducing agent. Okay, sir. And if element undergo reduction, it will cause oxidation of other. Then it will be oxidizing agent. Okay. What does it mean? Its simply meaning is कि if you see in this situation, so oxidation and reduction happen simultaneously. Redox reaction. Oxidation and reduction happen simultaneously. Redox reaction. Read plus reduction and oxidation simultaneously. It means If it is a situation of beggar and donor, so donor exists only because there are beggar. So, like if you are a good donor who donated 1 lakh rupees, it means there is someone acceptor who accepted 1 lakh rupees. So, if you are donor, you are responsible for the acceptor, like somebody else accepted your money. Correct? Same here. If you are undergoing oxidation, you are causing reduction of other. Because if you are undergoing oxidation means you are losing electron. It means other will gain electron, will cause reduction. So reduction and oxidation occur simultaneously. And in doubt, Sarah?
So no, sir.
So oxidation and reduction happen simultaneously. If this happen simultaneously, it means simultaneously. It also meaning is ki oxidation means reducing agent and reduction means oxidizing agent. In this question, when you have reducing power of the metal, means it can cause reduction of other. It can cause reduction of other. And when it cause reduction of other means itself undergo oxidation. Itself undergo oxidation. So you need to know which element will undergo oxidation. Okay. हेलो देख लिए क्वेश्चन ठीक है तो अभी क्लास में ही रहो क्योंकि अभी मैं एक्सप्लेन करना स्टार्ट कर रहा हूँ हाँ तो guys reducing power of metal means oxidation. In first question you have to identify which element will undergo oxidation. The easiest method is more positive value reduction, less value oxidation. So where you have least value in third you have the least value, so least value means oxidation. Maximum value Ag means reduction. Anybody have doubt? So answer will be B.
Yes. Understood, sir.
Anybody have doubt, guys?
No,
So
No,
sir.
sir.
solve question number 2. Tuhina. Zinc convert into zinc 2 positive. So reduction potential is minus this.
Yes, sir.
And Ag reduction potential is 0.34. In this situation, what will be your cell potential?
Sir, I'm not sure, sir.
So in this case, E cell will be equal to E of cathode minus E of anode.
-1.1.
Not minus plus, because you always get plus. And I told you ki you will never make mistake in this. Okay, so plus 1.1. How do we know, guys? The simplest method is ki we know that E cell is cathode minus anode. Cathode means reduction. So this is cathode reduction. And minus 0.76 means oxidation. And that's why it will be present on anode. Okay. So what is cathode value? 0.34 minus sign. What is anode value? Minus 0.76. So overall value 1.1. Anybody have doubt? Rohina, any doubt?
No, sir, no doubt.
Sarah. Third question. Standard reduction potential of half reaction given below. Strongest oxidizing and reducing agent. Sarah, tell me what is the meaning of strong oxidizing agent?
So, like, it undergoes a reduction.
Very good. It undergo reduction. And reducing agent means?
It undergoes oxidation.
Yes. Out of these four element, you have to identify which element will easily undergo reduction first based on these value.
Sir, keeping the option
Option
A.
yes, very good. This is correct. How do we know? Where we have maximum value of reduction potential? Fluorine. Maximum value means reduction. Minimum value means oxidation. So maximum value F2. That's why it will undergo reduction. If you see minimum value out of these four, iodine have minimum value. So it will undergo oxidation out of these four. Remember, oxidation reduction is always comparative. Always comparative, not standard. Any doubt? Anybody? Anybody have doubt, guys? Yes, Rayan. Fourth question. Standard reduction potential of three element is minus 1.2 plus 0.5 minus 3. Reducing power of this metal, same like first question. Reducing power means, Rayan?
Oxidation, sir.
Reducing power means oxidation. Which one will undergo oxidation easily?
Minus 3.0.
Minus 3.0 will have maximum value, so Z value will be maximum. So answer should be C. Done. Understood,
Yes,
guys?
sir.
Everybody? Reducing power means oxidation. And oxidation means you have to look for the minimum value. Minimum value is for Z. It means oxidation. Z value will be the minimum value. So oxidation and answer will be C. Anybody have question, guys? Cell potential you have to calculate. Barinder. Fifth. For Sn value is plus 0.15 and chromium minus. Barinder, tell me which element will undergo reduction and will go to cathode. Barinder, are you there?
Chromium.
Yes. Sn. How do we know more value? Here you have plus 0.15 and minus 0.74. Out of this plus 0.15 will undergo reduction, 74 oxidation. So reduction means cathode and oxidation means anode. And your E cell value will be cathode minus anode. Cathode value is plus 0.15 minus, what is the anode value? Minus 0.74. What should be the answer, Barinder? Barinder, what will be the answer for fifth? 0.89? 74 plus 15, 89.
Yes, sir. Yes.
Pratigya, sixth question.
Sir,
Yes, Rayan.
one more thing we can say, which is the maximum value we can take it as the reducing one, and the reduction one.
Not reducing, reduction. You are right. Yes. Yes. So maximum value means reduction, minimum value means oxidation. Best oxidation, minimum value. Best reduction, maximum value. Okay, Rayan?
Okay, sir.
Yeah. So, Pratigya, sixth question. And see,
सर मैं बोल रही हूँ
and Rayan, because you are new, you have to solve all the question. Even if I am asking other people, you have to write your answer, and
Yes.
at the end of the session, you will send me your notes.
Yes, sir.
Yes, Pratigya.
The answer C.
Answer C. Yes. If you see Fe3 positive will undergo reduction because more value, and I2 will undergo oxidation because less value, comparative less value. Correct. So Fe3 will undergo the reduction while iodine will undergo oxidation. If iodine will undergo oxidation, what will happen? I negative will convert into I2. This is oxidation from -1 to 0. So answer will be I negative will be oxidized to I2. So means oxidation. Anybody have question? Chandana, seventh question. direct direct formula. EMF of the electrochemical cell is first take reduction potential. Is third correct? Chandana, is third option correct? EMF is equal to reducing potential of anode plus reducing potential of the cathode. Chandana, are you there?
Yes.
Okay.
Sir,
Yes, Chandana.
yes.
In yes, Chandana.
Third is correct.
Third is correct. No.
So shouldn't it be
So
minus sign?
yeah. So you have to remember only one formula. EMF of the cell is equal to EMF of the cathode minus EMF of the anode in the reduction potential, RP only. If they give oxidation potential, it will be ulta. Correct. So you wrote E cell is equal to reduction potential of cathode minus reduction potential of anode. Okay. You don't have any option. Example, third option is definitely wrong. Why? You have positive sign in between. Got it? Now, if you convert into the negative value, so reduction potential of anode, if you convert this in the, let's take oxidation potential, so it will become negative, negative, negative will be positive. So it will be reduction potential of cathode plus oxidation potential of anode. Do you have this option? Plus sign, oxidation and reduction. So two will be definitely there. Any doubt, guys? Remember this rule. I've been telling you, and uh, I told you that you will understand through question. Ki EMF of the cell is equal to EMF of cathode minus EMF of anode in the reduction potential only. Only reduction potential. And if somebody give you the question from related to the oxidation potential, then oxidation potential value will be negative of the reduction potential. Okay. So 2 is possible, 3 is not possible. So A, C is not possible. Then you have to see whether fourth is correct or not. So you'll get idea. Oxidation potential of anode positive, okay. Oxidation potential of the cathode, yes, correct.
So
How?
option D, no, sir.
Yes, option D. How? Because for cell, you had reduction potential of cathode. Now it will become oxidation potential minus of for the cathode minus. For anode, it will be plus oxidation potential of anode. Then yes, you have fourth option. Ask me, guys. Okay, so never try to memorize all the formula, because if you feel ki, yes, I can do it, well and good, but content is more. Anybody have doubt, let me know. Chandana. No, Chandana, you already told. Tuhina, eighth question. Strongest oxidizing agent means? Tuhina?
So the one that reduces it the most?
Yes. Reduction. Reduction. So you have minus 3.35 and minus 0.77. Which one is more? Which one is more, Anvita? Oh, sorry. Tuhina.
So minus 0.77.
Is more.
No, wait, that the last uh minus 0.35, sorry.
This is more correct. So it will
Yes,
undergo
sir, yes, sir.
high value means reduction.
Yes, sir.
Correct. So
Yes, sir.
here FeCN64 negative will undergo reduction. What will be your answer?
Mm,
See, Fe2 positive convert into Fe3 positive plus one electron. So this is
yes, sir.
oxidation. If you make it ulta,
Hmm.
Fe3 positive gain one electron and convert into Fe2 positive.
Fe2 positive.
So what will be the value? Plus 0.77.
Yes,
Would,
sir.
will it be the highest?
No, sir.
Yes, it will be.
Oh, wait, 77. Yes, sir.
Because this value is
I
given
thought
in.
you said plus 0.35. Sorry.
Yes.
Yes, sir.
This
Understood.
was oxidation. What you have in the question is oxidation. You
Yes,
want
sir.
to convert into reduction, it will become ulta.
Yes,
Plus.
sir.
Anybody have doubt,
Sir,
guys? Yes,
yes, sir.
Pratigya, your
Here
question.
given oxidizing agent, blood reduction.
This is loss of electron, na oxidation. So oxidizing potential value
हाँ
is
तो
given
मतलब
minus.
रिडक्शन में मतलब मोर वैल्यू होता है ना.
हाँ, रिडक्शन वाला मोर वैल्यू होता है.
हाँ तो मोर वैल्यू तो -0.35.
रिडक्शन में मोर वैल्यू. यहाँ पे क्या है?
हाँ
यहाँ पे
हाँ
दोनों
ऑक्सीडाइजिंग
वैल्यूज
एजेंट मतलब
ऑक्सीडेशन में है.
तो है ना.
देखो, I'll tell you again. कि oxidizing agent means we want to find which one is undergoing reduction easily. Both the value given in this question are oxidizing potential. You have to first convert into the reducing potential. Sorry, yeah, oxidizing potential, oxidation potential is given to you. If you want to convert into reduction potential, you will have to use negative sign. So reduction potential of
Potential.
FeCN63 negative will be plus 0.35 volt, and for Fe3 positive it will be plus 0.77. अंडरस्टूड प्रतिज्ञा? ये यहाँ पे ऑक्सीडेशन की
नो
फॉर्म में
सर.
दिया है, ये यहाँ पे ऑक्सीडेशन की फॉर्म में दिया और हमें रिडक्शन की फॉर्म में निकालना है पहले तो. समझ में आया? ये हमें
नहीं.
ऑक्सी ये हमें ऑक्सीडेशन की फॉर्म में दिया हुआ है दोनों वैल्यू. पहले तो इसको रिडक्शन में कन्वर्ट करो, फिर कंपेयर करो. अब समझ में आया? दोबारा समझाऊं प्रतिज्ञा? प्रतिज्ञा, ठीक है. अब देखो, हमें क्वेश्चन में ये दिया है कि Fe2 पॉजिटिव convert into Fe3 positive and one electron. So this is oxidation. Fe2 positive converted into 3 positive. This is oxidation. And this oxidation potential value, E naught value is minus 0.77. First, you convert this into the reduction, make it ulta. If you make it ulta, Fe3 positive react with one electron, it will become Fe2 positive. So this value will be plus 0.7. प्रतिज्ञा नेटवर्क का इश्यू है, शायद तुम्हारा दोबारा से क्रॉस चेक करो एक बार नेटवर्क। नहीं नहीं, नेटवर्क इश्यू है प्रतिज्ञा।
हेलो सर।
हेलो, यस प्रतिज्ञा, समझी?
ये सर हो गए, मतलब वहां पर जो थे ना, मतलब -0.35 के बाद Fe2+ मैं वो नहीं देखी थी।
हाँ, वो तभी कंफ्यूजिंग लग रहा
हाँ।
है। यस, नेक्स्ट रेयान, 9th क्वेश्चन
ऑप्शन ए।
इन ऑप्शन ए। सो
ए प्लस हो रहा है, मतलब ऑक्सीडेशन हो रहा है।
हाँ, दिस इज
हाइपोथेटिकल इलेक्ट्रोकेमिकल सेल में अगर देखो तो ए प्लस है तो विच इज ऑक्सीडेशन, एंड बी प्लस में बी हो रहा है विच इज रिडक्शन। तो इन द इक्वेशन फर्स्ट विल राइट द ऑक्सीडेशन पार्ट, then we'll write the reduction part. So according to that, option A is correct, I guess.
correct. It is. So guys, remember we mentioned this in our notes. On the left hand side you draw oxidation, so this undergo oxidation, and right hand side part you draw reduction. Right hand side part, this is reduction. Okay, so and overall value is positive. Positive value means this is feasible. This is feasible, reaction can happen. So it means A will undergo oxidation, A will convert into A positive, and B positive convert into B. Done. Anybody have doubt? So you have 15 questions, so we'll directly move to the Nernst equation. Tara? See this. Question number 16. Ki Fe3 positive convert into 2 positive, so reduction. I negative will convert into I. For this, E naught cell is this at 298 Kelvin temperature. Gives free energy, you have to calculate. What will be your value, Sarah? Your answer. What is the formula if you want to calculate delta G value using E cell? Delta G is equal to minus NF E naught cell. Correct. Sarah, last formula we wrote in our notes was the same thing.
Gives free energy delta G equal delta G naught plus RT ln Q, right?
But you don't have this natural log Q in this case, so E naught cell is given, so you will use formula delta G naught is equal to minus NF E naught cell.
Which is for the galvanic cell.
Yes, galvanic cell. Yeah. So minus NF E cell. So using this, Sarah, tell me what is your answer. How many electrons are transferred in this case, Sarah? Sarah, how many electrons are transferred in this case? Sarah, are you there?
Yes, sir. Yes, sir.
Yeah. 2. Because sometime you will believe ki sir, Fe3 positive convert into 2 positive. So there is 1 electron difference, right?
Yes, sir.
So this is reduction, 1 electron gain, and I negative convert into I. So there is a difference of again 1. So N value should be 1. Answer is no. Why? For one atom, one electron difference. For two atom, two electron difference. Ultimately, two electron is transferred. That's why n value will be 2. This is most important. Remaining thing is minus n value 2. F value is already given 96,500 coulomb per mole. And E naught cell is also given 0.24. Tell me guys, was it difficult? Even without option, you can solve this question.
Yes, sir.
Yes. Jordan, I didn't ask you last question.
You didn't ask a single question, sir.
Well, too much discrimination you are facing every single day.
I swear, sir, so much doing, sir.
So do 17th question.
Sir,
Mom.
ask him all of the next questions, sir. My question also, you give it to him, sir.
Eh? Sir,
I
Jordan,
don't
you
mind,
want
sir.
more
It's okay.
questions?
I'll give sacrifice, sir.
Yeah, too much sacrifice you do every day. Jordan, see how lucky friend you have,
Sir,
man.
tell her to write notes fast, sir. She's asking me for notes during
Jordan,
class.
Jordan, I'll kill you, man, Jordan. That was at the start, okay? It was at like 7.
What?
Okay. See, she's sacrificing you, and you are
Putting me
what?
under the bus, sir. He's throwing me under the bus, sir.
What
Look
is
at
she
this.
doing right now? She's sacrificing herself, so I'm just helping her.
Yes, I'm helping, trying to help
I'm
you get
helping
more
you
practice,
also
Jordan.
Wait,
Being
sacrifice
a
wait, wait,
good
yourself.
wait,
friend.
wait. Guys, remember, this is not your house.
Sir,
This is
option D.
classroom.
Sir, you remember how much we used to fight in class, sir?
Yeah, you used to fight a lot in the class, but we will control for a few
So
minutes.
option D.
Because you know why I'm like stopping you to fight?
Too much
Sir, there are other
distraction.
people here, and it's going to be
No,
embarrassing.
no, because I don't have popcorn.
No, you're uploading this on YouTube also, no, sir.
Yes.
So option D. Option D.
Option D. Okay. So you have E naught value. You have N value in this case. Equilibrium constant value is given. E naught value is given. You have to calculate. So if you calculate E cell in this case, this is equilibrium condition. So E cell will be 0. Remember, E cell, EMF of the cell will be 0. If this is the 0, then your E naught value is equal to minus NF natural log K, right? Is this correct? Is this correct, Jordan?
Yes, sir.
But don't you think we don't need this if you know what is the number of electron involved in this case and it is 1 and value is 1?
So you can just omit it then.
So E cell which is equal to 0 at equilibrium, E naught cell is given 0.59 minus 0.06 divided by N value is 1, then log K, and you have to calculate equilibrium constant K value. So it will go another side will become positive. This cancel. 0.06 0.06 cancel. It will be 1 log K.
1 log K.
Uh,
And then 0.6 and 0.06, so you can basically move the
it,
decimal.
it will be 10. So it will be equal
10,
to D.
D.
10.
Yes, sir.
Why? Because your E cell is 0.06. Correct? Correct? No. It will be E naught cell which is given in the question 0.59. Like you have to consider 0.6. So if
I
you
mean,
calculate
if you round it
low
off, both
K
ways will be the
value,
same, no?
low K value will be 10. Yes, Jordan,
10.
your answer is correct. Yeah. Anybody have question, guys?
Um,
Mm, mm.
sir,
You you are confused. Let me. explain you. See,
How sir, no confused.
non-confused.
Answer is C.
E node cell, you consider it 0.6. Okay. And what else is given? Equilibrium situation is given. So, Jordan, in equilibrium situation, what will be E cell value, EMF of the cell?
It'll be
Zero.
0 because it's in
What is
equilibrium.
Nernst equation? E cell is equal to E node cell minus
Minus
0.06 by n
0.06 divided by n
log
log k.
k. This is 0. This is 0.6 minus 0.06 and value 1 log k. It will go to another side. 0.6 is equal to 0.06 log k. It will be 10. So log k value is equal to 10 and antilog of 10 will be 10 raised to power 10. Yes. Pratik, what
Yes.
were you asking?
हाँ सर सर वो लॉग का मतलब कुछ ध्यान नहीं है मुझे तो थोड़ा गड़बड़ हो गया
हाँ, तुमने लास्ट क्लास में कर दिया था ना, पहले तुम्हें लॉग बता देते हैं. I'll explain you log again and I will ask other people because they were there. Starting from the Barinder. Barinder, are you there? Barinder,
Yes, sir. Yes, sir.
what is log 1 value?
0
0. What is the log 2 value?
2.3
0.3. 0.301 people right, but you consider 0.3. Sarah, what will be log 4 value?
log 3
Log 4, can you write 2 raised to power 2? It's still equal to log 4. And the rule in the log is if you take log x raised to power n, your power will come into multiply. N
Sir,
log x. Yes.
सर ये क्लास कब तक है?
ये क्लास 12-1 बजे तक कोशिश कर सकते हैं हम चलाने के लिए.
पर इतना देर नहीं हो पाएगा.
नहीं, इतना तो मिनिमम. अगर नीट क्रैक करना है तो मेहनत तो करना पड़ेगा.
तो
हाँ
सच
सर मैं
में
आपके साथ हूँ
ओ
अरे नहीं, बस 1-2 क्वेश्चन कर रहे हैं, कंप्लीट होने वाला है. बैटरी
ओके
भी लो होगी के. हाँ.
यस
So
सर
log x raised to power n is equal to n log x means.
इसलिए तो बोली सर कि पहले बताना चाहिए, बैटरी को चार्ज करना पड़ता है.
सही बात है. So log x raised to power n is equal to n log x. Correct. Log 4 is equal to log 2 raised to power 2. 2, whatever the power will come into the multiply. So it will be what? Ram, Ruhina, Jordan, Brinder, Chandana is not there. So, Ryan, can we say log 2 raised to power 2, 2 will come into multiply? Log
Yes,
2.
sir, 2 log 2.
So 2 log 2 value is 0.3, it will be 0.6. So you need to know log x raised to power n is equal to n log x. Log x raised to power n is equal to n log x. So, Tuhina, tell me what will be log 8 value?
So you asked it last time also. It's log 2 to the power 3. So 3 log 2.
Log 2 raised to power 3, 3
3
log
into
2.
log 2.
3 into what is log 2 value?
It'll be around 0.9, sir.
Yes. Correct. So, Jordan, if log 2 value is 0.3 and log 4 value is 0.6, what will be log 3 value approximately? Between these two
It
values,
will be
0.3 and 0.6.
0.4
Up, we can't tell exact value like in our exam. because we will not get the log table. But you have to calculate approximate value. I guess it is
Yes, sir.
0.47 because I have read many times, but in reality you can't remember, to be honest. You can predict ki log 2 value 0.3, log 4 value is 0.6, so log 3 value in between these two. Okay, so next, log 10 value is equal to 1. Sarah, what will be log 10 is to power 2 value? 2.
Yes, sir. The power.
Yes. Ryan, what will be log raised to power 3 value?
Sir?
Log 10 raised to power 3.
3, sir.
3. So if you know all those log value, now you can correlate with the anti-log. Now you can correlate with anti-log. Ryan, press on this join audio button.
Yes, sir.
No, still not on. Press twice. So, Chandan, are you there?
Yes, sir.
Imagine log 10 raised to power 1 is 1. What will be anti-log of 1?
Sir, 10.
10 raised to power 1. Ulta. Exactly opposite. If you know log 10 raised to power 2 is equal to 2. Pratigya, what will be anti-log 2 value?
100.
10 raised to power 2. Correct? So in the simplest way, if you want to calculate anti-log, whatever is the number, same will be the power. Anti-log of 1. Anti-log of 1, 10 raised to power 1. Anti-log of 20. Uh, Tuhina, anti-log of 20.
Sir.
10 raised to power 20.
Okay. Yes, sir.
Uh, Ryan, what is will be the anti-log of minus 5?
Does minus 5 have any value?
Yes, 10 raised to power minus 5. Just power, whatever number is,
The power 10.
yes, whatever number is given for the anti-log, same will be available 10 raised to power. Done. So if anti-log of 1, power 1, anti-log of minus 3, 10 raised to power minus 3. Done. Yeah. Got it, guys. So anti-log is done. Let's do one, two question of the Nernst equation, and then we'll end this session. Who answered the last question? Jordan. Chandana, 18th.
Yes, sir.
Zinc zinc sulfate concentration is 0.01. Copper sulfate concentration is 1. Concentration is important. What is the formula in this case, Chandana?
0.6 divided by n.
Log product concentration divided by reactant concentration. Right? Product concentration divided by reactant concentration. Yes. Chandana, what will be on? What is n value in this case, Chandana?
2, sir.
N value is 2. What is the product concentration?
0.01.
0.01 because zinc 2 positive. What is the reactant concentration?
1.
1. And what else? you need in this case?
Sir, what is log 0.01?
Log 0.01 will be
10 power
log
minus
100.
2.
Log 100, na? So
10 power
log 100
minus
value.
2.
Yes. So EMF of this cell is E1. When concentration of zinc change to 1 and copper sulfate become ulta, then EMF will be E2. You have to calculate relationship between E1 and E2.
Yes, sir.
So when you calculate E1 value,
Sir, E1 is
E naught
equals to E naught plus 0.6,
03
0.606.
log what is the product? 0.011 by 100. And what is the reactant? 1. So log 1 by 100 value will be what? Minus 2.
Yes, sir.
Minus 2 means minus 0.06 E1 value. What will be E2 value, Chandana? E naught minus 0.03 log product by reactant. So it became ulta. Now it become
Sir, E1
1
is
by
equals to E naught minus 0.06.
E naught minus 0.06. And first E1 value was plus 0.06, right?
Yes,
Which
sir.
one is greater?
E1.
Then so you have to apply Nernst equation 2 times. In first case, Nernst equation like E cell value will get 0.06 positive. In E2 value 0.06 negative. Which one will be greater? First one. Anybody have doubt? Let me know. Anybody have doubt, guys?
No, sir.
So, what is your today's task? You already have PDF in the group. You have to finish these 32 questions before sleeping because 50% of the chapter. All the 32 questions with explanation. You can ask your doubt in time. So right now, you send me your notes. I will check while sharing the screen. Okay, then you can leave. Is this enough for today? 50% of the chapter.
Yes, sir.
More than enough.
More than enough. Yeah, it was too long, but
No,
it was
sir.
interesting. No? चलो अच्छी बात है.
Sir,
So,
can you send the recording to me, please?
yeah, sure. I'll send the full recording. $32 question. Did I record this question part? Let me check.
Yes, sir. Yes, sir.
Oh, thank God. I did. I will stop recording.